Okay, hello class. Welcome to the deformation of actually loaded member part 4. In this video, i-discuss ko yung sample problem number 3, which is similar to the problem number 2 sa previous video natin sa part 3. Now the problem is a bronze bar is fastened between a steel bar and an aluminum bar as shown in the figure. In this example class, the member is not made of homogeneous materials, no? Kasi may steel, bronze, and aluminum, so iba-iba ang properties nito. Magkakaiba ang modulus of elasticity. Action loads are applied at the positions indicated. Find the largest value of P that will not exceed an overall deformation of 3 millimeters, or the following stresses: 140 MPa in the steel, 120 megapascal in the bronze, and 80 megapascal in aluminum. Assume that the assembly is suitably braced to prevent buckling, and then the modulus of elasticity are 270, 83 for steel, aluminum, and bronze respectively. Now, ito yung figure as shown. This is made of steel, 1 meter length, bronze 2 meters, aluminum 1.5. And the loads are applied dito sa positions indicated. So, in terms of P, ang load dito is P, dito is 3P, dito is 4P, and then at the other end is 2P. Now, the condition is we need to determine the largest value of P na hindi mag-exceed sa overall deformation of 3 millimeters or the following stresses. Na may given na stress. So, what is the deformation ba? At the total deformation is given. So, ibig sabihin, kukunin natin yung equation ng deformation for every material, for steel, bronze, and aluminum. So, in this example, deformation steel is equivalent to, same pa rin, PL over AE. So, this is applicable for steel. P ng steel is P, kasi kapag nag-section ka, section muna tayo. Considering left section, kapag dito, nag-section ka dito, 1 section, considering section 1, 1, okay, so you have P here, load P, so therefore, internal force probably is away from the section na kinonsider mo. Now, okay, so that is P steel is equal to P. Okay, so hindi na ako nag-step by step summing up. Makikita mo naman yan, away to the right. So, P steel is equivalent to yung to the left naman. So, P. So, P steel, the magnitude of P steel is equivalent to P. So, this is P steel. So, we have P steel here, or overall, okay, overall, let's make it PL over AE na steel. So, that is equivalent to P. P steel is P. Then, the length is 1 meter. So, sabi ko kanina sa unit analysis, sa second part ng video natin is in millimeter. So, express L of steel in millimeter. So, that is 1,000 mm. So, ang assumption natin, P is in Newton. Area, the cross-sectional area is square millimeter. So, for 80 square millimeter, then the modulus of elasticity for steel is 200,000 Newton per square millimeter. Kung bakit 200,000 Newton per square millimeter ang ginagamit ko, check nyo na lang sa part 2. No? Okay, so this is now the deformation of steel. Formation of steel is simplify natin, 1,000 divided by 480 by 200,000. That is equivalent to 1 over 96,000. P over 96,000. Okay. Okay, in millimeter na to, no? And P in Newton. Then for a bronze, sa bronze naman, for section naman tayo dito. Let's say 2-2. Okay, considering 2-2, we have we have 3P here, 3P, and then meron ka ditong P. So obviously, you need to counteract to maintain equilibrium. So the internal force dito sa bronze will be, magkita mo naman summation of forces along x equal to 0. We have 3P less P bronze less P is equal to 0. So P bronze will be equal to 3P minus P, which is equal to 2P in compression. Kasi towards the section siya. So this one pala is in tension. Okay. So, substitute lang natin. So, the deformation of bronze will be equal to P ng bronze is 2P. 2P times L, length is 2,000 mm, divided by the cross-sectional area, which is equivalent to 650 square millimeter. 650 square millimeter, and then the modulus of elasticity is equivalent to 70 gigapascal. So, meaning meron ka ditong 70,000 kasi in megapascal siya. Kinonvert natin in megapascal. So, the deformation bronze will be equal to, simplify, 4,000 divided by 650 by 70K. Okay. So, we have P over 11375. Okay. So, next is, okay, this is the deformation of bronze. So, this is positive. Ito ay less kasi compression. Okay, last. Let us cut the section dito sa aluminum. Considering the right section, same results lang naman yun. So, consider this as 3-3 section. Considering 3-3, we have this one. Cut. So, you have 2P. The internal force here, obviously, is away. So, this is P aluminum. Okay. So, summation of forces along X, we have P aluminum is equal to 2P. Now, substitute the deformation sa aluminum. Sorry. Okay, deformation aluminum will be equal to 2P times L. PL over AE lang din ulit. So, 1,500 divided by the cross-sectional area is 320 and the modulus of elasticity is 83,000. Okay, so simplify the deformation ng aluminum will be equal to 3,000 divided by 320 by 83. Okay, so we have 3P over 26560. 26560. This is in tension. No? Tensile. Kasi yung 2P natin ay tensile. So, plus lang din siya. So, the solve na natin. Total deformation is the summation of PL over AE. Okay, so condition sa problem, the overall deformation should not exceed 3 millimeters. So, ito yung total deformation natin, 3 mm. That is equivalent to yung deformation ng steel plus deformation ng bronze plus deformation ng aluminum. We have P over 96,000 plus or minus less kasi compressive yung sa bronze minus P over 11375 plus yung sa aluminum tensile. So we have 3P over 26560. Okay, considering 3 mm here, sum up nyo lang yung right part of the equation, makukuha natin that the value of P is equivalent to, okay, so 1 over 96,000 less 11,375, 1 over 11,375, add 3 over 26560. Okay, then 3 divided by answer P is equal to P, considering the total deformation, P will be, makukuha natin that the value or the magnitude of P is 84. Sorry. Okay, 84,610.99 Newton, or in kilonewton, siya ay 84.6. P is 84.61 kilonewton. No? So, okay, considering the total deformation of 3 mm, but in the problem, overall or the following stresses, 140 MPa in the steel, 120 MPa in the bronze, and 80 MPa in the aluminum. Considering the stress naman, yung allowable stress, makukuha natin yun by kasi pwede mo namang i-consider yung stress, stress equivalent to P over A. Ano? So, P over A yung tawag dito. I-consider mo. Gamitin mo lang yung idea ng mga previous topics natin. So, pag chinek mo yun, makikita mo dito that sa steel, diba sa steel, nakita natin that the P is P, na? Okay, so, sabi dito, dito the allowable stress ng steel is 140 MPa. Okay, since from the equation we've seen that we have found out that P steel is equal to P. Okay, since ilagyan natin ng boundaries. Ito considering deformation yung taas. Considering stress naman, P steel is equal to P based from the cutting section. Yung internal force is equivalent to P. And then the stress ng steel given sa problem, which is equivalent to 140 MPa, 140 megapascal, diba, equivalent din yan sa P over A. What is the cross-sectional area of the steel? That is equivalent to 480. Magkakaroon ka ng 140 is equal to P over 480 square millimeter. So, the answer here is in Newton. So, P is equal to 140 times 480. So, that will be 67,200. 67,200 Newton, or 67.2 kilonewton. Now, considering bronze naman, from here, we have found out that the P bronze is equivalent to 2P. Okay? P bronze is equal to 2P, and then the stress ng bronze is equal to, the allowable stress is 120 megapascal. Okay, here. 120 megapascal. Okay, considering um, P over A, the cross-sectional area is equivalent to um, 650 square millimeter. 650 square millimeter. So, therefore, we have 120 is equal to force per unit area, the 2P divided by the cross-sectional area, 650. From here, we can determine that P is equivalent to 120 times 650 divided by 2. That is equivalent to 39,000. 39,000 Newton, or P is simply 39 kilonewton. Okay, so we have P here, we have P here. Ito yung P, and then i-compare natin at the end. Now, let us consider the aluminum. The aluminum P aluminum is equivalent to how much of P? P aluminum is twice of P. P aluminum is equal to 2P, and then ang kanyang allowable stress is 80 megapascal. And then the cross-sectional area of the aluminum is 320 square millimeter. Now, apply the stress formula. We have 80 is equivalent to 2P divided by 320. So, P will be equal to 80 times 320 divided by 2, 12,800. 12,800 Newton, or P is simply 12.8 kilonewton. Okay, comparing the four results, considering the maximum allowable deformation of 3 mm, the P is 84.61. Considering the stress sa steel, ito naman yung allowable P, result of P. Then for bronze, 39, and then for aluminum, 12.8. So the final answer is equivalent to 12.8 kilonewton. Why? Because what is being asked in the problem is what? Okay, the requirement of the problem is the largest value of P that will not exceed an overall deformation of 3 mm or the following stresses. Okay. So, kapag ang load mo is 12.8 kilonewton, so hindi yan mag-exceed ng 140 kasi nga, ang kaya ng steel is until hanggang 67.2 kilonewton, as well as the P bronze, 39, ganun din yung considering the total elongation, ang P mo is 84.61. So, how much more kung 12.8 lang yung P? So, syempre, masyadong, kumbaga kayang-kaya, hindi mag-exceed. So, if you are required to determine the maximum safe or the largest value of P or ng load, lagi mong pipiliin is the smallest one because kasi para kaya ng lahat when it comes to overall deformation, when it comes to the allowable stress. Okay, this is the final answer, 12,800 Newton or 12.8 kilonewton. Okay, that's all for this video.